Okay, these are the notes for 5.5, section 5.5, double angle formulas. What I mean by double angle is that I have 2 times an angle. So sine of twice an angle, tangent of twice an angle. There are 3 formulas for cosine, but they'll all get you the right answer. It doesn't matter which one you use. Sometimes it's easier to use one than the other, and I'll show you why. So cosine of twice an angle could be cosine squared of the angle minus sine squared of the angle. If you replace sine squared with 1 minus cosine squared, you get this formula. If you replace cosine squared with 1 minus sine squared, you get this formula. So it doesn't matter which one you use, and you don't have to have these memorized for this class. So my first example, start out like I did the last lesson. I just want to see if 2 times sine of pi over 6 is equal to sine of 2 times pi over 6. So I write the equation again, but I put a question mark over the equal sign. I replace sine pi over 6 with 1/2. 2 multiplied by 1/2 is going to be 1. When I multiply 2 multiplied by pi over 6, I get 2 pi over 6, which is going to be pi over 3. So the sine of pi over 3 is going to be square root of 3 over 2. So no, these are not equal. That's why we need to have the double angle formulas. So my first example, I'm going to be given an angle, a sine of the angle, and I'm given more information. What that's going to do is it's going to allow me to see what quadrant I need to draw the angle in. So I have sine of the angle theta is equal to negative 4 over 9. And I know my angle is between pi over 2 and 3 pi over 2. So that means it has to be in the second quadrant or the third quadrant. Sine is positive in the second quadrant, but negative in the third quadrant. So I'm going to go ahead and draw this in quadrant 3. Once I draw it in quadrant 3, opposite is negative 4. Hypotenuse is 9. I can find my third side. It's going to be negative square root of 65. Then I just write the formula again. So sine of 2 theta is equal to 2 sine theta cosine theta. I replace sine theta with negative 4/9 from you looking at my diagram. And I replace cosine theta with negative square root of 65 over 9 using my diagram. Then I'm just going to go ahead and multiply. Negative 4/9 negative square root of 65 over 9 gives me a positive 4 square root of 65 over 81, and I have to double that. So 8 square root of 65 over 81. Then I would check it with my calculator. If I know that the sine of the angle is negative 4/9, I can do inverse sine and I can find the angle. Just remember that I want to find the one that's in the third quadrant. Once I find that angle, I double it, and then I take the sine of that angle and I check with a decimal. And that's how I check it with a calculator. Okay, my next example, I have cosine of theta is equal to square root of 2 over 5. I'm either in the first or the second quadrant. Well, cosine is positive in the first quadrant and negative in the second quadrant. So I know I have to draw this in the first quadrant. So the square root of 2 is the adjacent, 5 is the opposite side. I use Pythagorean theorem and I find my opposite side is going to be the square root of 23. And at this point, it doesn't matter which of the 3 formulas I use for cosine 2 theta. I'm just going to go ahead and use the first one. So cosine 2 theta equals cosine squared theta minus sine squared theta. I fill in cosine, which is going to be square root of 2 over 5, and I square that. And I fill in the sine of theta, square root of 23 over 5, and I square that. Square root of 2 over square root of 2, or square root of 2 multiplied by square root of 2 is 2. 5 multiplied by 5 is 25. Same thing here. Square root of 23 multiplied by the square root of 23 is 23. 5 multiplied by 5 is 25. So then I have a common denominator. I can subtract the 2. And I get negative 21 over 25. And once again, I would check with a calculator. My last example on this side of the notes, I'm given tangent and I want to find tangent of 2 theta. So I'm given tangent is negative. It's negative in the second quadrant and the fourth quadrant. This is telling me that sine is negative. Sine is negative in the third quadrant and the fourth quadrant. So this angle has to be drawn in the fourth quadrant. So I draw this in the fourth quadrant. I mark my opposite side -3 and my adjacent side 7. I find my missing side, which is square root of 58. I write the formula down. Tangent 2 theta is equal to 2 tangent theta over 1 minus tangent squared theta. I replace all tangent thetas with the values. Tangent is -3/7. So you'll see I didn't even need the hypotenuse for this problem, but if I asked for sine or cosine, I would have. And then 1 minus -3/7 squared. Now I just be careful with the math. 2 multiplied by -3 is -6/7. -3/7, when I square that, becomes a positive 9/49. When I get a common denominator and the denominator of this problem, 49/49. So when I subtract 9 from 49, I get 40/49. So -6/7 divided by 40/49. When you divide by a fraction, you multiply by the reciprocal. So I flipped 40/49, made it 49/40, and I multiplied and reduced my fraction. I get -21/20. And then I would check that with my calculator. A couple more examples on the back. Okay, these ones now I'm going to be solving the equations using double angle formulas. And just like before, there's infinitely many solutions when you're talking sine and cosine or tangent. So we're only going to find all the solutions between 0 and 2 pi. That just makes our work a little bit less daunting. So my equation is I have 2 cosine x plus sine 2x. So sine 2x right there, there's my double angle. I want to replace sine 2x with 2 sine x cosine x. So what happens is I get 2 cosine x plus 2 sine x cosine x equals 0, just replacing the sine 2x. Now I go back to my techniques I learned before. I have cosines and I have sines. So in this case, I cannot just isolate one of the terms. I'm going to have to factor the GCF. In this case, my greatest common factor is going to be 2 cosine x. So when I factor 2 cosine x, I'm left with 1 plus sine x. And remember, you have to put parentheses around this term here because you're multiplying, and it must equal 0. Then I set each factor equal to 0. So 2 cosine x equals 0, and 1 plus sine x equals 0. When I solve these, cosine x equals 0, sine x equals -1. Now I want to find the angles. If cosine x equals 0, x is going to equal pi over 2 and 3 pi over 2. Sine x is equal to -1 when x is equal to 3 pi over 2. Since I have 3 pi over 2 in both places, I don't have to write it twice. So I'm just going to box those for my answers. And then I would check with my calculator. Take these values, plug them back into the original equation. My last example for this section is going to be cosine 2x plus cosine x plus 1 equals 0. Since there are 3 different formulas I could use for cosine 2x, I could use any of them. But this is a case where it's going to be easier to use one just with cosine in it because I have a cosine here and a cosine here. I don't have sines. So I'm going to replace cosine 2x with 2 cosine squared x minus 1. So I get 2 cosine squared x minus 1 plus cosine x plus 1 equals 0. I combine my like terms and I'm left with 2 cosine squared x plus cosine x equals 0. I can factor the greatest common factor, which is cosine x, put it in the front, open parentheses, 2 cosine x plus 1, end parentheses equals 0. Once again, these parentheses are really important and the 0 is very important. Set each factor equal to 0. So I get cosine x equals 0 and 2 cosine x plus 1 equals 0. Cosine x is equal to 0 when x is equal to pi over 2 and 3 pi over 2. Solve this for cosine x. Subtract 1, divide by 2. I get cosine x equals negative 1/2. So I get x is equal to 2 pi over 3 and 4 pi over 3. So all my answers, the pi over 2, the 3 pi over 2, the 2 pi over 3, and the 4 pi over 3. It doesn't matter the order. A lot of times books want them in order from least to greatest. I'm not going to care which way you write it. You could even box both these answers here. But then I would just check with a calculator by plugging these values back in.